Hello guys, welcome to our video today. First of all, I'd like to say how sorry I am for not teaching the class that I was supposed to teach last Monday, when was it? July 6th. I'm sick. I still have fever. I'm still sick, but I'm a lot better. So I'm recording this video to introduce to you Chapter 7, and our new topic is networking. I want to make it very clear that next Monday we are going to have our weekly meeting, so we're going to have our class. And this video today replaces the class that we were supposed to have last Monday, July 6th. Okay, so our focus here is going to be on networking. That's our e-textbook chapter 7, okay? And this is a topic that I myself am very fond of. Well, obviously for obvious reasons. This is what I do. This is where my background is. That's what I've been studying for most of my life and working with. But I would say that it's very important to understand some concepts involving networking for different reasons. And I would say that the main reason is because nowadays there is no resource, or at least no digital resource that you may use that won't involve networking. It won't involve digital communication. And if it involves digital communication, the traffic is flowing through the network. So what I'm trying to say is that it's critical to understand how networking works and also how to connect devices and the components that you may have available. Now, you don't have to deeply understand how communication works, but you do have to know the most basic, most important components that you have when it comes to networking, to digital communication. So you have to know, for example, what are the components that I need in case I want to deploy a network. Let's say that it's a home network. So what type of technology are you going to use? Are you going to use wired? Are you going to deploy a wired network, a wireless network? Why? What is involved? You have the performance metrics. You have also cost. So you have to take a lot of metrics into consideration before actually deploying it. You're not supposed to simply go there and say, okay, I'm going to use a wireless network in my house. Okay. In general, that's a good solution, but depending on what you have, it could not be. So, for example, it depends on how big your place is. It depends on even on how many mirrors you have in your place. So, if you are in a big house or not even a big house, but if you have many mirrors inside your house, wireless networks, especially Wi-Fi, wireless fidelity, which is the standard, the industry standard, you're going to have some problems. Obviously, you can overcome those problems, but you have to know how to do that. That's what I want to discuss and talk about here today. So that's our chapter, networking, connecting computing devices, and our learning objectives are describe computer networks and their pros and cons, explain the different ways networks are defined, describe the types of transmission media used in networks, describe the basic hardware devices necessary for networks, describe the type of software necessary for networks, summarize the broadband options available to access the internet. We also have some other objectives, such as summarize how to access the internet wirelessly, explain what should be considered before creating a home network, as I mentioned, described how to set up a home network, described the potential problems with wireless networks and the means to avoid them, described how to secure wireless home networks. Okay, so first of all, let's talk about networking in general, or computer networking in general. Well, as you may already know, a computer network is a resource that allows you to interconnect, allow the communication between different network devices. So, for example, you may have your laptop, your desktop, your smartphone, iPad, and your kids, they have their own smartphones, they have their Xbox, PlayStation. So different devices. Nowadays, you also have literally all different types of devices that can access the internet and can, if not access the internet, they can at least communicate with other devices that are sitting inside your home. So, for example, you can have your smart TV that has access to the internet, so you can watch Netflix, but also the sound is being broadcasted to the home theater sound boxes that you can have, and the communication can happen using, for example, Bluetooth. It could use DLNA. There are different protocols, different standards that allows one device to communicate with other devices. Now, how does this communication work? For this communication to work, there must be what is called a protocol. And the protocol is nothing more than a set of rules that will determine how these different devices will communicate. So it's the same idea such as anything in life. Whatever you want to do, there are a certain set of rules that you have to follow in order to achieve that goal, in order to get what you want to get, right? So, for example, let's say that you are getting ready for the fall. So you have to pick the courses that you're going to take. Well, once you do that, there is a set of rules that you have to follow. For example, you have to, first of all, check whether you have permission to take those courses or not. Are there any prereqs for those courses? If there are, do you have those prereqs? For example, oh, this course depends on that other course, but I didn't take that other course. Okay, so therefore, you can't take this course. You have to take that other course first. So let's say that then you find the courses that you want to take. You know that you can take those courses. But now you have to make sure that there are seats available. Maybe there are only 10 seats available and they're all full, right? So there is a bunch of stuff that you have to do before you actually achieve what you want to achieve, right? Also, what's the idea? What's the good of taking a course that you're interested in the content of that course? It seems to be very interesting. It's in a good day, good time, so you can go there and take it. But then you realize that, oh, okay, for some reason, the instructor here only speaks Portuguese, for example, and I don't speak Portuguese. That's a lame example because obviously the university wouldn't do that. But if you're not considering the logic here, but only the set of rules, this is a rule that exists, and you have to be ready for that. So the protocol, the network protocols, they work the same way. They define some rules, some ground rules, and you have to follow those rules. And to follow those rules, you have to know those rules. So It's not only a matter of understanding that rules exist, but you have to know the rules. So if we go back to the same example of a TV, a smart TV connecting to the internet and broadcasting the sound to the Bluetooth system. Well, the communication between the TV and the Bluetooth, the home theater system, the communication will happen using a specific protocol. For example, Bluetooth. Not only the TV must talk Bluetooth, but the home theater system must comprehend that protocol as well. So that is how the communication, a network communication, works. And actually, that's how any type of communication works, not only computer networks, but any type of communication, right? I'm Brazilian. My native language is Portuguese, but I have to speak in English, or at least try to. Otherwise, I won't make myself understood. You won't be able to understand what I'm saying. So there are some ground rules that everybody here must understand. Now, the benefits of networks, as we know, sharing a high-speed internet connection, and this is not something very old. It's actually pretty recent. So back in the day, we were able to communicate, but the communication wasn't happening using a high-speed internet connection. For example, I remember very clearly when I first started using internet and playing online games, that is back in 1995, 1996, maybe 1994, at least down in Brazil, only the rich people had connectivity that would go up to 36 kbps. So look, 36 kilobits per second, and I'm talking about bits, not bytes. That is very, very slow. Obviously, for that time, that was like spectacular. That was amazing. But imagine nowadays you having that type of connection. And so, okay, I'm talking about roughly 25 years ago. Well, that's not long. That's not too much at all. If we go back, let's say 10 years, 15 years, let's go back to 2010. The internet connection that we had, at least the commercial use that we had for the home clients 10 years ago was, I would say, maybe 2 megabits per second, 1 megabit per second, which is just unbearable. It was impossible to have the streaming services that we have nowadays only 10 years ago. But obviously now we do, and this connectivity allows us to do a bunch of stuff. More specifically, if we try to generalize, we can use the word sharing. So that's what connectivity or network computers allows us to do. Share stuff. So share printers, peripherals, files. You can share any type of resources, right? There is a disadvantage, mostly is the setup and administration. And obviously you also have you can also have some problems regarding performance. But the good thing is that nowadays performance is very much associated with setup and administration. Why do I say that this is a good thing? Well, because if it's associated with administration, that means that you can change, you can fix it, right? Because the speed, as I previously mentioned, is very high. So the resources, the technology is there for us now, right? It's just a matter of knowing how to do that. how to deploy it. So how data moves through networks. We have to understand how the data moves through networks. But before we do that, there are some concepts that we have to understand. First of all, and we hear this, we listen to this all the time, data transfer rate, or more commonly said, the bandwidth, is the maximum speed data can be transmitted. So for example, when you're hiring a internet service from the internet service provider or ISP, most of the times you're going to hire that service based on the bandwidth, right? That bandwidth that you're hiring is telling you how fast your communication can go, how fast it can be, it can reach. It doesn't say that you're going to have that speed the entire time. So if you're hiring a internet service of, let's say, 100 megabits per second, are you going to have 100 megabits per second the entire time? No, you won't. Most likely, just a very short period of time will give you that transfer rate or that bandwidth, but you know that you can achieve that. The throughput is the actual speed data is transferred. So this is the average, right? So, and it's measured in megabits per second or gigabits per second. And once again, observe here that we're saying bits, not bytes. Usually you use bytes when you're talking about file size. You don't use file size in bits, you use in bytes. And when it's transmission, you use bits, transfer rate. You also have the classifications for networks according to their reach or their distance, right? So you have the personal area network, that is basically that's what you have at home. You have the local area network, that's what you have at your company where you work. So that's a LAN, that's the most common deployment and the most common nomenclature that you're gonna see when it comes to network classification according to size or reach. You also have, now, back in the day, you would see PAN, LAN, MAN, and WAN. Those were the nomenclatures, the classifications that you'd see. Well, but computer networks became so common, especially with their arisal of the so many appliances connecting to the network in the internet, that they also created the concept of a home area network. Now, it's funny because if you observe the difference between personal area network and home area network, there is no difference when it comes to distance or reach. But it's more a home area network is associated with the type of devices that are connected to that network. So let's say that you have just a network between your smartphone and your laptop. Well, you can have your laptop sitting on your home office and your smartphone is in your hand while you are in the living room, right? Well, that's the same distance between, let's say, your smart TV and I don't know, your fridge. Let's say that that's the same distance. But the communication, the network between your smartphone and your computer will be classified as a PAN network, personal area network. It's different from a home area network where you're going to have the communication between the TV and the fridge. Okay, so it's more about what is connected there. Now, you can expand that to other types of networks according to their distance. So we have the metropolitan area network, MAN, and the wide area network, or WAN. Now, this becomes very blurry, very cloudy. Differentiating these networks gets very cloudy because, for example, okay, so we have a metropolitan area network. What is that? That's a network that establishes a communication between different devices that reside within the same metropolitan area. So let's say that we have one node residing in two nodes residing in Tallahassee. Okay, they are in a MAN. Okay, what if I am establishing a communication between a node in Crawfordville and Tallahassee, right? Okay, that seems like a metropolitan area network. Okay, what if we expand that a little bit more? What if we analyze two nodes, one sitting in Tallahassee and another one sitting in Panama City? Well, that doesn't look like a metropolitan area network anymore, but that's too close to be classified as a wide area network. So as you can see, these are some concepts and definitions that we have, but they are not very precise. They can become a little bit cloudy, especially nowadays with the entire planet being interconnected. We can also classify networks according to the type of communication or the role of a node or nodes within a communication. So, for example, it's very common to see nowadays. Back in the day, we would only see client-server networks. What's a client-server architecture? Well, that is an architecture where you're going to have one node or several nodes that they are providing a service. So those are the servers. Whereas other nodes, they're not providing anything. They're only requesting. So they are clients. You have a very clear illustration of roles here. One is serving, that's the server. The other one is receiving that service, so that's the client. Nowadays, it's very common to see networks where those roles are not very clear for one specific reason, because that is not a client-server communication, client-server architecture, or client-server network, whatever you want to call it. It's very common to see nowadays peer-to-peer networks. And in many situations, you're going to see this identification here, P2P. That stands for peer-to-peer communication. Okay, so in that type of structure, a node can be a client, but it can also be a server at the same time. So if you use torrent, that's one situation. If you use a very simple situation, you have within your residency, you have your smartphone, and your smartphone is downloading something, a file from your laptop, but at the same time, it's transferring a photo, an image to the iPad, for example. So in this type of communication, you have a peer-to-peer or ad hoc structure. It's not very clear who is the client, who is the server, because you cannot tell that apart. They're not performing those specific roles. You can also classify networks according to the data link protocol. And here we get to the protocol itself, or the protocols themselves. So first of all, we're not going to discuss the TCP/IP stack or the OSI stack of protocols model, but you have to understand that in a communication, it's not just one protocol. Well, at least in, let's say, 99% of the times, a communication is not occurring using just one single protocol. There is a stack of protocols. One protocol does one thing or one set of things, and another protocol running on top of the first one will do other stuff, and then there's going to be another one that is going to do another stuff. But in a generic way, you have those different protocols that are doing specific stuff. When it comes to transmitting signals and transmitting bits, transmitting information, not data, not analyzing, for example, if you're accessing a website, or if you are transferring a file, or if you are sending an email. That's not the case here. We're just going to analyze bits, how bits are going to be transferred, are going to be transmitted. To establish that, you also have a protocol or a set of protocols. And regarding the transmission of bits or signals, the protocol that will take care, or the protocols that will take care of that, they are down there in a layer called the data link layer. And in the data link layer, we have different protocols. However, two are the most common ones that, at least that we have in our houses or in where we work. Those are the Ethernet, and obviously this can be classified. It has other classifications. You can have a fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, and so forth, so on. So many different subclasses of Ethernet. But what you have to understand is the Ethernet is the standard for the wired data link, which means when you're connecting to the network using that blue cable, most likely you're using the Ethernet data link protocol. If you're using a wireless network, most likely you're using a standard called Wi-Fi, which stands for Wireless Fidelity. Basically, those are the two most common standards that you have. Okay, I also use Bluetooth. Sometimes I use infrared. I use Zigbee because I'm an enthusiast, and I like, let's see, I like to use Raspberry Pi, Arduino, and I'd like to use Zigbee. That's another technology that I like. Okay, fine. That's awesome. It is there, but I'm talking about the two most common ones. If it's wired, probably Ethernet. If it's wireless, probably it's Wi-Fi. Now, let me go here. Now, when you're using a wireless or a wired network, there are some components that you have to know. First of all, let's take a look at the wired network. Right here. In a wired network, the biggest difference that you're going to see between the wired network and the wireless network is the presence of the connection cable, right? Which, as I mentioned, usually you're going to use that blue cable. Okay, you have so many other colors, but that's kind of a standard, the blue cable. Now, regarding the other components, they follow different standards, different protocols, but they do the same thing. For example, okay, you need obviously your computer, okay? You have your computer, whether you're using a wireless or wired network. You also need the interface, the network interface. It can be wired or wireless, but you need it. You have to connect that device, your device, to a concentrator. If it's a wired network, this concentrator right here will be most likely a switch. If it's a wireless network, you're going to have that access point right there, or wireless modem. Okay, fine. Now, but there is no cable here, and this is what makes the entire difference between these two networks here, right? What's so big between these two? What's the big deal about having the wired communication and the wireless communication? Well, if you have a wired communication, the data is being transmitted through what is called a guided media. And here you're using a non-guided or unguided media, right? Well, you can see that this has a lot to do with security, right? First of all, security. Second of all, performance. Well, why security? Well, if your signal is being transmitted through the air, any device that has a wireless interface, a communication interface, will be able to capture that traffic and will be able to read that information. Here, that's not going to happen. Only those that are actually connected. I'm not saying that just having a wired network will give you a certain level of security. That's not what I'm saying. I'm just saying that it is safer in that sense that the communication is not being broadcasted through the air. But you still need levels of security. You still need some security resources in order to increase the security here. Performance. Well, if the signal is being injected in a very strict, precise, and guided media, it will perform a lot better than when it's being broadcasted in a unguided media. Why? Because since it's being broadcasted through the air, other access points, for example, can also be transmitted in that same transmitting in that same frequency. And not only access points, but for example, if you have a microwaves, they work in the same spectrum of, well, not if you're using 5G, the 5G frequency, but if your device works in the 2.4 gigahertz frequency, your microwave is going to impact on that performance. A wireless phone, just the same. So there are so many different devices, home appliances, that can actually impact in the performance here. Also, since it's non-guided, you can have some barriers, right? So let's say that your device, your concentrator here, the access point, sits in your living room and you are trying to watch a Netflix video in your phone, laying on your bed, right? Well, first of all, there is the distance. There is a loss of performance of signal due to the distance. Plus, you also have obstacles between your living room and your bedroom, right? So that is why wireless networks, specifically Wi-Fi, wireless fidelity, is a very it's a technology that became very common because it's comfortable, it's easy to deploy. However, it has so many limitations. Therefore, you have to do a bunch of analysis before actually deploying this type of solution. You have to analyze whether this is the best solution for you or not. There are situations where the wired network is should be your pick. Let me give an example. If you need performance, gamers, for example, if you're a gamer, each millisecond of delay may make a difference. For example, if you're a gamer and you play games, shooting games, killing games, right? The moment that you click a button to try to shoot your opponent, you click, but let's say that you're using a wireless network, it's going to generate a delay. That milliseconds delay, it can be, let's say, 10 milliseconds delay can make the difference between you killing or getting killed. And that's the situation in many different, for many different, this can happen in many different situations. Now, it's getting common and more common to see fiber optics getting to your house. Fiber optics are very expensive, and this is why back in the day nobody would have it unless you were a big company. Because big companies, they need this type of performance, this high-speed internet connection, because they don't want to, for example, they don't want to lose a sale because the system is not going as fast as the client expects, right? So let's say that you go to a dealership, a car dealership. You want to trade your car. You're going to get a new car. So you sit there in front of the sales rep and he's there, and you ask him or her, hey, do you have this specific car, this specific vehicle with this description, this color, whatever that is. And then the sales rep is going to go in the system and try to find that specific vehicle that you're looking for. But it's taking too long. And why is it taking too long? Because the system is processing. And why is it taking 30 seconds just to process that request? Because the internet connection is slow. Okay, you're not going to wait. You're going to stand up and you're going to find another retailer. Well, so they don't want that to happen. Fine. But at home, back in the day, we didn't, if when you perform a search in Google, so you open Google, you access Google, and you enter whatever you want to search for, and it's not going to make a big difference waiting, let's say, half second or 1 second to get the result for what you're looking for, right? You can wait an additional half second if you're paying, let's say, $50 a month. That's a lot better than, okay, I don't want to wait that extra half second, so I am going to pay $200, $300 a month. Well, I don't think so, right? But that was back in the day. Nowadays, we are having fiber optics getting to our place, getting to our house. So the wired communication evolved not only in regards to how the protocol works, but also the physical components that they use, and the material used to transmit the signal plays a very important role. So we started with the UTP cable, actually with the coaxial cable, then we evolved to the UTP cable right here. The UTP cable is that blue cable, and nowadays we can see fiber optics getting to our place. Okay, so we have our components. We have the media, the transmission media, which can be guided or unguided. And we also have the broadband technology that we're going to use. It's very common to see now, well, not only nowadays, this has been there for a while, to have cable internet and or DSL internet. But as I mentioned, now we also see fiber optics, and there are some new technologies coming up, right? So a lot of people nowadays, they don't have fixed internet connection. So they don't have DSL, they don't have cable, they don't have fiber. Why? Because they use their 5G technology, their mobile data technology. And so they use their phone, their smartphone, as a router to transmit connectivity to the appliances and all other devices that we have in our home, right? But these are some solutions that we had: cable, DSL, fiber optics. Right here, so you can use your smartphone as a personal hotspot. You can use your 4G, 5G connection to broadcast connectivity to the devices that you have in your home. And at least in an iPhone, this is how you do it. Now, before you deploy your network, let's say that you decided to go for a wireless network. There are some information that you have to gather before you actually do it. So first of all, you have to have a list of all the devices that you're going to use, all the devices that you want to connect to that network, and specifically to the internet, right? You have to use the latest standard, or at least you should try to use the latest standard. What does that mean? Well, not only use the newest equipment, but if that equipment, although it's the newest one that you have available, you also have to make sure that it's running the latest standard. So check if there is an update, a firmware update, which means whether you can update the system that is running in that concentrator, as you can see here, that hotspot, that access point, or if it's already the latest. If it is, that's great. You also have to have a list of all the devices that you're going to connect to your network, because that number of devices and the type of traffic that they will generate will impact on your performance. Now, this is a very interesting setup and also very common setup. Here, you have a mix of wireless and wired network. Even if you use an entire wireless communication to broadcast the signal to all the appliances and devices that you have in your home, most likely that modem or that access point is physically connected to the cable that the ISP is bringing to your house. So probably the cable guy, for example, will come to your place. It's going to plug in a device there, that access point, and it will have a guided connection. It will use a wired connection, and then it will broadcast the signal that arrives to it to the other devices that you have in your network. If not, if you don't want to use a wireless network, this is the setup that you're going to have. All devices will be physically connected. They will use a guided media. This is a component that is becoming more common every day. So that's the network attached storage device. Since, first of all, the storage capacity that we have in our devices nowadays, they're not enough anymore. So even though you may have an external hard drive or a flash drive or even a big hard disk in your machine, there is a very high probability that storage component, that storage device will get full eventually. So people are starting to use these network attached storage devices because you can not only attach more than one hard drive, you can attach several devices, but more than that, you can have several network devices storing data in that component. So this is not a device that is attached to one specific device. It's not attached, physically attached to your laptop, for example, to your smartphone, for example. It's another peripheral, it's another appliance that you have in your home. The difference is it doesn't do anything but to store data, and you can send data and retrieve data, send data to it or retrieve data from it, from any device, any other device, right? Another one that is becoming very, very common is the media center or the media centers. You can very well have a network attached storage device where you can install a media center, a specific software in it that will run a media center. And what is a media center? It's nothing more than a box connected to the internet that also has a storage capability, but it also runs a media center. And what is that media center? It's a software that will transmit, reproduce audio and video that is stored in it. So it's a box that is storing files, but if it has audio and video, it can reproduce it for you, for your TV. It can send it to your TV. It can send it to your smartphone. It can send it to your home theater system. And there are so many different solutions. For example, a video game can become a media center, such as Xbox or PlayStation. Now, some important information regarding your wireless network setup. In case you're having issues, keep this in mind. Maximum Wi-Fi range is about 350 feet. About. Obviously, as I previously mentioned, it will depend on the number of walls that you have between the access point and your device. It will depend on the type of barriers that you have in between. For example, if you have mirrors, then it's not going to reach that distance for sure. So walls, floors, large metal objects are sources of interference with wireless signals. Place an access point where the Wi-Fi signal becomes weaker. A wireless range extender repeats or amplifies wireless router signal. This is a very good resource. I use it in my place. So let's say that first of all, there is one resource that you have to use if you want to have a good wireless network deployed in your apartment or in your house. And it's called site survey. So what is the site survey? Site survey is a situation where you're going to try to find out the best location to place your access point. You try to find where you should place your access point in order to get access to all the devices that you have in your home. It doesn't matter if a device is in the kitchen, in a bedroom, another bedroom, or even in a bathroom. You want to have access everywhere. But to do that, to find that proper location, you have to do site survey. So to do site survey, you have to place the concentrator, which is the access point, in a location, and then use, for example, your laptop or your smartphone. There are softwares to help you with that. So let's say that you use your smartphone with a proper software, a proper app, that you go to your bedroom and it's going to measure the signal. Then you go to the bathroom, then you go to the kitchen, and you go to the living room. You go to all places measuring the signal. Then you move the access point to a different location and you do it all over again. Well, doing that, you'll be able to say, okay, if I place my access point in my living room, in my rack, that's where I will get the best. In average, that's how I'll get the best performance for my wireless network. Okay, fine, great. If you do that, it works perfect. If it doesn't, even doing that, you cannot get access if you are in the bathroom. Okay, what can you do? You can use a wireless range extender or repeater, or a signal repeater, or also called a WPS. What is it going to do? It's going to work at the same time as a client, as just another node, and as another access point at the same time. How? It will work as a client because it will receive the signal from your, let's say, main access point, but then it will repeat that signal, but stronger, to the other environments that you have in your place, right? So that is another good resource that wireless networks can give you. Now, regarding wireless network security, keep in mind that you have to use encryption and security protocols. Now, nowadays, there are still people that use WEP or WPA encryption standards. No, don't. You have to use WPA2 at least. Okay, it's common to see people using WPA2 personal at home. That's fine. Ideally, you want to use WPA2 enterprise, but that's a difficult setup. It's not a trivial, the setup is not trivial because you're going to need an authentication system, you're going to need credentials. So that's there is a certain level of complexity involved. Therefore, you can use WPA2 personal, but don't use WEP, neither WPA, because they are easily cracked. So use encryption, change the network name. A wireless network name is called SSID. So here I have my Wi-Fi connection right here, and my SSID is called Diogo Meires 5. I also have, which I can't see here, but I also have the same one, but ending with 2, Diogo Meires 2. And these other ones are from my neighbor apartments. Now, first of all, change the network name. Why you're supposed to change the network name? Well, because you don't have to have that standard. Why? Let's say that you just purchased your access point, and by default, the network name, the SSID is, let's say, wireless. Okay. If someone, let's say a hacker, sees that network, that wireless network with name wireless, and he knows that's the standard for a specific vendor and a specific model. Well, if that person wasn't even careful enough to change the SSID, most likely he or she didn't change the credentials. He will try to get access to your access point and may succeed. If he or she doesn't succeed, we will at least degrade your performance because an attack will be happening. Disable SSID broadcast, and that's what we have right here. As we can see, I can see my neighbors' SSIDs. This wasn't supposed to happen, ideally, right? So ideally, you don't want to have other people seeing your wireless network name there. If someone wants to connect to your network, let's say that you have a friend that just came to your house and he wants to have connectivity, that person should ask you, hey, do you have Wi-Fi network here? And you're going to say, yes, I do. That's the SSID. That's the password. So you're going to give it to him. But you don't want other people to see that you actually have it, because if this happens, that's one last step. Look, if I want to crack this network here, I don't have to guess the SSID, the network name, only the password. Obviously, it's not easy, but at least it's one last step. Obviously, you have to change the default password and create a passphrase. Some other implementations which are very useful, very resourceful, and people don't do these ones. Implement media access control, so you can access your access point and say, okay, these are the devices that can connect to my wireless network. You can limit the signal range. You can keep router firmware up to date and disable remote access. So as I previously mentioned, if a hacker sees that you have, there is a wireless network in your apartment, and that person is going to try to access your access point, try to crack it. Well, if you disable remote access, now you just made it a lot harder for him to get access to your network, or at least to cause damage. That person can get access even if you disable remote access. He can try to crack the password, but at least he or she won't be able to access the configuration of your access point and cause more damage. And this is just one example of how you can do it in accessing your access point to change this type of configuration. Here you're defining the encryption, so WPA2 instead of WPA or WEP. You can see that WEP here is not being deployed, and that's also where you can define the range of your signal, disable remote access, and so many other stuff. So in this class we discussed how wired and wireless networks work, and some security concerns and performance that you have to keep in mind. I hope you enjoyed this class. Thank you very much, guys.